Okay, class, welcome to the last unit, Unit 7. We're going to be using what we've learned about derivatives and even antiderivatives and use them in applications. On day 1, we're going to deal with related rates. It's going to be a lot of word problems again, but we're going to apply what we learned about implicit differentiation. If you recall, implicit differentiation, that we always added an extra ddx or prime to it. So an example like this, the ddx of 4y to the third was 12y squared with an extra y prime on it, or 12y squared with the dy dx. This one would be 10r with an extra r prime, or 10r with an extra dr over dx. And this last one would be negative 6u to the negative 4 with an extra u prime, or negative 6u to the negative 4 with the du over dx. So that's what we're working on. We're going to apply it to a different situation today. We're going to be looking at taking not the ddx of something, but the ddt with respect to time. ddx was with respect to the variable x. So when we deal with these word problems, they're called related rates because we're taking the derivative with respect to time. So we're doing a ddt of something. So we're always adding that extra thing to it. So this one would be not just 12x squared, but we'd have to put in an extra dx over dt because we're asking about the rate of change of x with respect to time. Or shorthand, we could do 12x squared times x prime. This would be 10r times dr over dt, or 10r times r prime, because this is dealing with the rate of change of the r, let's say radius, with time. This would be 24y to the third times dy over dt, or 24y to the third times y prime. So every variable that we're doing is getting an extra, d dt, no matter what the variable is. Doesn't really matter. So these, I can do, this one isn't too bad, negative 12x to the negative 4 with a dx dt, or negative 12x to the negative 4 times x prime. Now these I should rewrite. I should rewrite this as 5r to the 1/2, and this one I should write as 6h to the negative 1/3 power. So I'm going to take its derivative. This one would be 5 over 2 r to the negative 1/2 with a times dr dt, or 5 over 2 r to the negative 1/2 times r prime. Everyone uses a shorthand, and this one would be negative 2h to the negative 4/3, and then we would put in an extra dh dt, or negative 2h to the negative 4/3 with an h prime. So every variable, when we take its derivative, will have an extra prime added to it. We only did it for the y's before when we did implicit, but because now we're always taking the derivative with respect to time, every variable, whether it's an x, a y, an h, and r, is always having an extra x prime, y prime, dr over dt, whatever you want to call it. So we need to know our formulas from geometry class, whether it's circumference or perimeter or area or volume or this and that or the other. Most of these you should know already, but I'll probably give you most of them on any assessment that we have. So let's look at this problem. For any given right triangle, if one side is x, the other leg is y, and the hypotenuse is z, the Pythagorean theorem is going to be x squared plus y squared is equal to z squared. That is the Pythagorean theorem. So now I'm going to take its derivative. So I'm going to rewrite it. I'm going to take the d dt of it all. Not the ddx like we did before. I know we did this before. Now we're taking the derivative with respect to time, so we're getting 2x times dx over dt plus 2y times dy over dt equals 2z times dz over dt. I'm going to write it out longhand. At some point I will write it out shorthand, but I see every term has a 2 in it, so I can get rid of a 2 everywhere. I'm going to divide by 2 everywhere. I get x times dx over dt plus y times dy over dt is equal to z times dz over dt. And this is the derivative of the Pythagorean theorem when I have the sides x, y, and z. And if you notice right now, I'm going to pull this up. There are 6 items here. This is the length of the x side. This is the rate of change of that x. Here's the length of the y side. Here's my rate of change of y. And obviously I have the length of the z side, and I have the rate of change, or the derivative, of side z. Now if you want to write it in shorthand, we could do x times x prime plus y times y prime is equal to z times z prime. And from now on, if I ever have a Pythagorean theorem type of problem, you do not have to start off with x squared plus y squared equals z squared and take its derivative. You could just always use the one in purple or the one in pink as the derivative of the Pythagorean theorem. And then we have to realize, what out of those 6 things, what do we know, what don't we know, and what do we need to find? Well, I gave you a right triangle. I gave you a 3, 4, 5 right triangle. It was nice I gave you all 3 sides. I don't have to give you all 3 sides. If you know 2 sides of a right triangle, you know all 3 sides. Use Pythagorean theorem. I gave you 2 things. So the horizontal side is increasing at a rate of 1 inch per second, while the vertical side is also increasing at 1 inch per second. Okay? So what do I know right now? I know side y is equal to 3, and its derivative, dy over dt, is equal to 1. X is equal to 4. Its dx over dt is equal to 1. And side z is equal to 5. And the derivative of that, I don't know that. Now if you want to call this y prime and this x prime and this z prime, that's it doesn't matter to me. We could start off with the Pythagorean theorem derivative, which is x times x prime plus y times y prime is equal to z times z prime. And right now, I know 5 out of these items. I know x is 4 times 1 plus y is 3 times 1 is equal to side z, which is 5. And the only thing I don't know is z prime. Well, I add this together, I get 7 equals 5 times z prime. I divide by 5, and I get z prime, or dz over dt, is equal to 7 over 5. And my units, I need to make sure I have my units. And since these were in inches per second, side z is also inches per second. You could leave it as a fraction. If you want to write it as 1.4, you can write it as 1.4. Okay, now let's see how the area is changing. Well, for a right triangle, I know area is equal to 1/2 base times height, or in this case, 1/2 side x times side y. And oh my goodness, looks like we're going to have to use product rule. So I have 1/2 x, and that derivative is 1/2 times x prime, and then y, and its derivative is y prime, and I can do my crisscross. So I get dA over dt, or a prime, is equal to 1/2 x prime times y plus 1/2 x times y prime. And that is the derivative of the area of this right triangle. And then I could fill in with what I know. What do I know? Well, a prime equals 1/2, x prime is 1, y is equal to 3, plus 1/2, x is equal to 4, y prime is equal to 1, and I multiply this out, I get 3 over 2 plus 2, and I get my derivative. I'm going to change colors here. A prime, which is my change in area over change in time, is equal to 3.5, or 7 over 2. Well, this was inches per second. This was inches, so I get square inches per second. You need to have units. That is how the area of that triangle is changing, as the x side is increasing by an inch per second and the y side is increasing by an inch per second. So let's do this problem. We're going to go back to our triangle that we had before, that the y side was equal to 3, the x side was equal to 4, the z side was equal to 5, but then I have things that are changing. The horizontal side, x prime, is increasing, that's 2. The vertical side, y prime, is decreasing, that's -1, and my z prime is what I don't know. That's what I'm trying to find. So I have x times x prime plus y times y prime is equal to z times z prime. I could put in what I know. I know 4 times 2 plus 3 times -1 is equal to 5 times z prime. 8 minus 3 is equal to 5z prime. 5 equals z prime equals 5z prime, and I divide by 5. I get z prime is my change in z over change in time is equal to 1 inch per second. So when the horizontal side is increasing by 2 inches per second and the vertical side is decreasing by 1 inch per second, the hypotenuse is increasing by 1 inch per second. So like I said, this unit is going to be a lot of word problems. Here's an example. We have a snowball that is melting, that currently the radius is 20 and the radius is decreasing at 3 centimeters per minute. When I see this, something like this is a rate or a derivative. The key is centimeters per minute. The word per is definitely going to lead to the effect that it is a rate of change. So what do I know right now? In the moment, right now, I know my radius is equal to 20 centimeters, and my rate of change is my r prime, or my dr over dt, is equal to negative, because it's decreasing, 3 centimeters per minute. Okay? That's what I need to pay attention to. So what do I want to do? I want to take this problem, and I want to take its derivative, the ddt. Well, what are we trying to find? We're trying to find the dv dt, or the v prime. So I want to take its derivative. What do I get? I get dv over dt is equal to, don't get cut up, 4/3 pi is just a constant. It goes, or is just a multiplier, a coefficient. It goes for a free ride. 4/3 pi times derivative r to the third is 3r squared times dr over dt. Okay, I could clean some of this up. I'm going to call it v prime is equal to, the 3's cancel, I get 4 pi r squared times r prime. That means me cleaning it up. And what do I know? I know r, I know that. So I get v prime is equal to 4 pi 20 squared times -3. I'll put the units in later. I multiply it out. I get my dv over dt, which is v prime, is equal to, well, 400 times 12 is negative 4,800 pi. And let's see. These were centimeters squared. These were centimeters per minute. So my units are going to be cubic centimeters per minute. And it is decreasing because I have a negative rate of change. Don't forget your units. Okay, so we have a rock thrown into a pond, making circular ripples, moving outward from the point of impact. And I know that the radius, I want to know how the radius is changing, because it's changing. Well, I know the radius is changing, and I have it's changing at that. It is increasing at 3 feet per minute. I want to know, how is the circumference changing? Well, two things I know right now is my radius is equal to 4, and my r prime, or my dr over dt, is equal to positive 3. This is feet. This is feet per minute. So when I take its derivative, my d dt, I get c prime is equal to 2 pi times r prime. So I could put in what I know. The radius doesn't matter here. Times 3, and I get my rate of change of my circumference is equal to 6 pi. Let's see, I have feet per minute as my units. Positive 6 means the circumference is increasing. I could do the same thing. I'm going to take my d dt of this, and I get a prime is equal to 2 pi r times r prime. And I could put in the things I know. A prime is equal to 2 pi. My radius in the moment is 4 feet. My r prime is equal to 3 feet per minute. And my rate of change of my area, or my a prime, is equal to 2 times 4 times 3, which is 24 pi. And my units are, let's see, this was feet, this was feet per minute. So my units should be square feet per minute. Okay, you should be able to do the daily assessment on your homework. Thanks for watching.